In this video, we'll walk through caliper mounting and adjustment for cantilever brakes with smooth post. Make sure you're watching the caliper mounting and adjustment video that matches your brake type. If you're not sure what you're dealing with, watch this video. In the cantilever brake system, there are two arms pulled toward the rim by the cable from the brake lever. These arms swing into the rim on an arc sweeping downward. The pivot for the arm is below the braking surface. There are many styles of the cantilever brake. Two basic styles are the non-threaded or smooth post. These small lines here are actually witness marks that just help us position the arm. And the threaded post. A nut will go on this and tighten up to keep this pad from falling off. In this video, we will look at the non-threaded or smooth post brake. Typical tools required are a hex wrench for tightening pinch bolts, combination wrench for pinch bolts and for pad setting, cable cutter for cutting the cable, torque wrench to ensure proper security, grease for the brake frame fitting and the spring, and thread locker for the mounting bolt. The cantilever brake mounts on a frame fitting that allows it to pivot. This fitting will hold the bolt and hold it secure. It's a good idea, if the brake has been on and off a few times, to put a little removable thread locker inside. The outside of the post should get some lubrication. It's common these are made with 3 holes, upper, middle, and lower. These holes permit adjustment to the overall spring tension. If I place it in the topmost hole, the tension begins quite early. It's going to be a very strong spring action. If I start in the bottommost hole, starts much closer to the rim, it's going to be a weaker. The spring is wound up less. It's a weaker feeling in the brake. Generally, start with the middle hole. It is important that the left and the right brake be on the same mounting hole. The mounting bolt is then installed. It's a fairly modest torque. 4 Newton meters is a common setting and really all you need here. There's our 4. There are different designs to connect the left and right caliper arms. We'll complete the rest of the procedures here using a link unit. At the end of the video, we'll install the straddle wire carrier and show where the process is slightly different for these systems. The common mechanism to join the caliper arms is the link unit. These do come in different lengths, A, B, C, and D. The correct length will give us good mechanical advantage. If we choose the right link unit, we're going to have our arms approximately parallel from the mounting bolt to the brake pivot bolt. That will keep us the best mechanical advantage. Too long of link unit does not allow good mechanical advantage. Too short of link unit will also not allow good mechanical advantage. We're looking for approximately parallel from the mounting bolt to the caliper to the bolt that is holding the pad. To install the link unit, there's an access port for the primary wire. Feed the wire through that and out the end of the housing. Next, we will engage the primary cable in the vertical slot. Now we hook the quick release end in one arm and feed the cable through the pinch mechanism in the other. Make sure there is contact between the housing and the caliper arm. If we have selected the correct link unit, A, B, C, or D, we will have the alignment slot in our link unit head in line with the cable, and our arms will be approximately parallel. At that point, we're going to secure the pinch bolt, and this flattens the cable. Next is to approximately center the arms. Don't worry about the brake pads, that's why they're purposely pointing down. Squeeze the lever to allow the arms to find their natural position. And now we're going to use the centering screw to bring the arms to the rider's left. If you don't have a centering screw, you can skip this step. We're doing an approximate centering now, so later you'll only need minor centering adjustments. There are several pad adjustments that need to be done correctly, and there are several different designs that allow for that. This brake and our example brake on the bike share the same design for securing the pad. This is the smooth post system. So the pad can be moved in and out toward or away from the rim. Additionally, there's a curved washer system, one on either side, that allows us to set the toe. There's a slot that lets us go up and down for height on a braking surface, and then the face of the pad can be angled so it strikes the face of the rim correctly. Everything is secured with a single nut. If you loosen it, you may lose your other settings, so this particular design can be quite frustrating. This caliper has similar settings with convex and concave washers on the back, but this tab and this wedge are very unique. It's rotated, and that changes the angle of the stud, and that changes the toe. This caliper has all the similar adjustments. What's unique on this one is that the toe is set through the smooth stud. We loosen it, and that allows the pad to slide on curved surfaces, and that sets the toe. Older caliper designs may be less sophisticated. This pad has some of the same adjustments from the caliper, but there is no up and down on the braking surface. The pad is simply rotated for height, and the single nut is secured. Back on our bike, we removed the tire to allow the camera a clearer view of the pad adjustments. It's time to move the pads to the rim. We loosen the back nut, we hold with the front. That allows us to make our adjustments. Now here we want to bring the pad to the rim. We don't want to push the arm over. Again, we've already set our arm in a working position, so we're going to bring the pad to the rim as if it is in a working position. So we're going to hold and snug. We're looking pretty reasonable, but we have no toe whatsoever. If the brake is set flat and the bike is used and there is no squealing, then it doesn't need toe. As you squeeze the brake hard, it tends to jiggle back and forth, the whole brake moves slightly, and then it causes a resonance or squeal. We can set a very slight gap in the back, tighten it that way, and it helps reduce the squeal because it tends not to be pulled back and forth so quickly. If you're happy with the position, hold and secure. Repeat the process on the other side. Again, bring the pad to the rim. Don't push the arms around. Squeeze the lever with force. This tests the cable pinch bolt. It's also going to help settle in the housing and cable. Now it's time to set the pad clearance set by feel at the lever. We're not worried about pad centering yet. That comes later. Too tight of lever means we barely pull this and we're automatically contacting. Any out of true problems at the rim means we're going to have a rub. Additionally, it's going to be very difficult to remove our quick release lever. Now, let's show you what too loose a lever would mean. To test too loose a lever, pull the lever again to the bar. It should not contact or come extremely close. You want at least an inch away from the bar. This would be too loose of lever. It would not be supplying good stopping power to our brake. In either case, you would now use the barrel adjuster such as on this bike here. Unscrewing the barrel adjuster away from the brake lever effectively lengthens our housing, takes out slack, and tightens the brake setting. Screwing the brake lever inward effectively shortens our housing, relaxes the cable, and gives us more clearance. On bikes with no barrel adjuster, make the adjustments at the caliper arm with the pinch bolt. Here, we can use the BT2 to control the cable to either take out slack or give more slack as is appropriate. Secure the cable pinch bolt and test at the lever. We're not hitting the handlebar. We can easily undo our quick release. And normally the setting on the front would then be duplicated for the same feel on the rear. Next, we'll center the pads to the rim. Remember, the two arms are connected. Moving one arm will also move the other. We're going to use a change in the spring tension with the centering screw. If we tighten this screw, it increases tension on the side that it's on and pulls the pads this direction. Loosening the screw will weaken this spring tension. This spring will draw it back to the opposite side. So here, we have a large gap over here. We need to tighten the screw, increasing the tension. When they look like they're centered, they are good. Good to go. If you do not have a centering screw, you can asymmetrically align the pads, and our arms will effectively do the same thing. Next, we give it a spin, seeing if we're touching any part of the rim and that we're clearing the tire. And now we're ready to cut and cap the cables. We're using footage shot from a different brake video, but the process for trimming and capping the cable is still the same. We don't want it too short. We won't have enough cable to work with in the future, nor do we want it too long. I can cut about here, put an end cap on, and that's going to give me enough cable to work with, and it will let me tuck up the cable back into the brake in a tidy fashion, and it's ready to go. Now we're going to go back and show where the process is slightly different with the straddle wire carriers. Setting the carrier height is important for good mechanical advantage in braking. Going up way high is very poor mechanical advantage. The brakes are trying to pull upward, they're not trying to move into the rim. So we come down fairly low, but never get the bottom edge of our carrier below this section of the fork. From here, we will tighten the pinch bolt, and this will flatten the cable. That is what's going to hold it tight. Take the straddle wire and pass it through the straddle wire carrier. Engage the head of the straddle wire in one arm and pass the cable through the pinch mechanism of the other arm. Now, we're going to pull or relax the cable to get our brakes at a good working angle. If we pull too much cable out, we've gone beyond parallel. So our two brake arms here are now as if pinched shut. That's past good mechanical advantage. If we don't take enough slack out, you can see here, this angle and this angle here are now outward. That is also not good mechanical advantage. So this is a very good use of the fourth hand, such as the BT2. It helps us control until we see this arm and this arm approximately parallel. Then we're going to secure. It will again flatten the cable. The pads are then positioned to the rim, as we have already seen. Then the pad clearance felt at the lever is also the same as shown before. After pad clearance, visually center the straddle carrier, then lock it in place. Some models do not offer a locking mechanism, and if it gets bumped, it could make the pads off-center to the rim. Simply push it back into center. The rest of the process is the same as before. If you're looking for help on a different procedure relating to rim brakes, we've got a whole series, and watch this video for an explanation how we've organized our rim brake video content. Thanks for watching, and be sure to subscribe for the latest from Park Tool.